a tiny blue dot, floating in the vast cosmic ocean. On this planet live everyone you know, and every person who has ever existed. Here, every story ever told by humanity has unfolded. This is the starting point of our journey. When we fly beyond Earth's atmosphere, past the moon, beyond the familiar planets and the sun, we embark on an epic voyage. A journey to explore the true scale of the universe. Leaving Earth's embrace, the first milestone in our cosmic journey, is the moon. It lies about 380,000 kilometers away, so distant that driving at 100 kilometers per hour would take over 160 days to reach. From the moon's perspective, Earth is a fragile sphere of blue and green, nestled quietly in the darkness of space. This sight evokes a profound sense of smallness. This is Earth as seen from the moon. Venturing further, the next stop is the sun. The sun is about 1 astronomical unit from Earth, roughly 150 million kilometers. The basic unit for measuring distances within our solar system. Imagine light traveling at 300,000 kilometers per second. It takes about 8 minutes and 20 seconds to reach Earth from the sun. If we traveled aboard a passenger jet flying at 900 kilometers per hour, the journey would take about 19 years. Such immense distances remind us how vast space remains, even within our own solar system. The sun is a blazing giant star, and even from this great distance, it provides our planet with the energy necessary to sustain life. Pushing further outward, we turn our gaze to Mars, our mysterious red neighbor. At its closest approach, Mars is about 55 million kilometers from Earth. But when the two planets lie on opposite sides of the sun, the distance can stretch to about 400 million kilometers. To put it another way, traveling to Mars at passenger jet speed would take more than 50 years. This vast distance makes exploring Mars incredibly challenging. The probes and rovers we send to Mars must not only traverse extremely long distances, but also overcome the complexities of ever-changing Earth-Mars distances and orbital dynamics. Continuing toward the edge of the solar system, we encounter the distant ice giant, Neptune. Neptune lies about 4.5 billion kilometers from Earth, marking almost the outer limit of our solar system. Sunlight takes about 4 hours and 15 minutes to travel from the Sun to Neptune. This staggering distance highlights the immense scale of our solar system. The Voyager 1 probe, launched in 1977, embodies humanity's endless curiosity and desire to explore the unknown. For over 40 years, it has traveled more than 22 billion kilometers through space, becoming the most distant human-made object from Earth, a silent wanderer in the cosmic ocean. In 1990, at the suggestion of renowned astronomer Carl Sagan, Voyager 1 turned its camera toward Earth one last time and captured a famous image, the pale blue dot, from about 6 billion kilometers away. Our planet appeared as a tiny, faint speck of light in the universe. Sagan reflected poetically on this image, reminding us of our responsibility to cherish and protect our only home, a tiny speck of dust in the vast cosmos. At the outermost reaches of the solar system lies the Oort cloud, a theoretical, giant shell of countless icy objects. It is speculated that the Oort cloud may extend up to about 100,000 astronomical units from the Sun, roughly 1.6 light-years away, so distant that it verges on interstellar space. Scientists call the boundary of interstellar space the heliopause, where the solar wind is halted by the interstellar medium. At this boundary, the Sun's influence ends, and the vast expanse of interstellar space begins. The Oort cloud can be seen as the final frontier of the solar system, where the Sun's gravitational influence gradually fades, and our cosmic journey truly enters the Milky Way's vast domain. Beyond the solar system, we turn our attention to the nearest star system, Alpha Centauri. It lies about 4.4 light-years away, equivalent to nearly 300,000 astronomical units. On such enormous scales, astronomical units become impractical, so astronomers prefer to use light-years to measure interstellar distances. With current space travel technology, reaching Alpha Centauri is nearly unimaginable. For example, Voyager 1 travels at about 17 kilometers per second. Even at this speed, it would take over 70,000 years to reach our nearest stellar neighbor. This astonishing distance makes us realize how vast the space between stars truly is, and highlights the immense challenges of interstellar travel. Now we come to the grand scale of the Milky Way. Our home galaxy spans about 100,000 light-years, a vast spiral galaxy containing hundreds of billions of stars, each potentially with its own planetary systems. Within this immense structure, there's an incredibly small spherical region, known as the human radio bubble. It extends about 100 light-years outward, representing the farthest reach of human influence in the universe, the distance our radio and television broadcasts have traveled. Beyond this bubble, it is as if humanity never existed. If other civilizations dwell in most parts of the Milky Way, they remain entirely unaware of us, as our signals have not yet reached them. The scale of the Milky Way is so vast that the entire history of human civilization is but a faint whisper in the cosmos, inaudible beyond that tiny radio bubble. Leaving the Milky Way, we enter the unimaginably vast expanse of intergalactic space. Here, galaxies are like islands floating in a cosmic ocean, separated by extraordinarily vast distances. Our Milky Way belongs to a small cosmic neighborhood, known as the Local Group, which contains over 50 galaxies, spread across about 10 million light-years. The Local Group includes large spiral galaxies like the Milky Way and Andromeda, as well as many smaller dwarf galaxies. The scale of this group is so immense that light takes 10 million years to travel from one end to the other. This makes any distance within the Milky Way seem trivial, further emphasizing the vastness of the universe. Intergalactic space is silent, like a wilderness between islands of galactic light. In this great void, our Milky Way, the repository of all our history, is but a tiny speck among countless galaxies, a mere story in the grand cosmic library. Pushing our view beyond the Local Group, we encounter the even larger Virgo supercluster. It consists of many galaxy groups and clusters, including the Local Group, spanning a diameter of about 110 million light-years. As a giant structure in the universe, the Virgo supercluster contains thousands of galaxies, which belong to at least 100 galaxy groups or clusters, each hosting countless stars and planets. Moving further outward from the Virgo supercluster, we arrive at an even more astonishing structure, the Laniakea supercluster. This vast collection of galaxies encompasses the entire Virgo supercluster, stretching over 500 million light-years. This is our cosmic home on a grander scale. Laniakea, meaning immense heaven in Hawaiian, lives up to its name. The total mass of the Laniakea supercluster is equivalent to 100 quadrillion suns, a magnificent tapestry woven by gravity, where countless galaxy groups and celestial bodies are interconnected, forming an immense cosmic web. At the heart of Laniakea lies a mysterious region known as the Great Attractor, exerting a powerful gravitational pull on the galaxies within this supercluster. In this vast expanse, our Milky Way, the entire Local Group, and even the Virgo supercluster are but tiny components of this colossal structure. Laniakea provides a profound context for understanding our place. Within this immense supercluster, we are merely a minuscule part of a grand system, far beyond our comprehension. As we reach the limits of this cosmic exploration, we glimpse the edge of the observable universe. The observable universe spans about 93 billion light-years, which raises an intriguing question. If the universe is only about 13.8 billion years old, how can it be so vast? The answer lies in the expansion of the universe itself. Since the Big Bang, the universe has been stretching and expanding, increasing the distances between celestial bodies. Yet what lies beyond the observable universe remains one of the greatest mysteries in cosmology. Some regions are moving away from us faster than the speed of light, making them forever beyond our view. Thus, the true scale of the entire universe remains unknown. It may very well be infinite. The observable universe is already unimaginably vast, yet it might only be a small fraction of the entire cosmic territory. Contemplating this fills us with humility. There may always be regions of the universe, galaxies, and wonders we will never witness, as they drift away, eventually disappearing into the depths of an ever-expanding cosmos. When we zoom back from the 93 billion light-year boundary to this tiny blue dot, I often reflect. The universe is boundless, and we are but insignificant specks of dust. Yet it is precisely because we are small that we need one another even more. A glance upward, a word of greeting, a light in the window. These are humanity's ways of defying the void. We may never reach the depths of the stars in this lifetime, but we can make this planet brighter, leaving our curiosity to the cosmos and our kindness to those around us. In our limited lives, let us live each ordinary day with purpose. The next time you gaze at the night sky, remember the pale blue dot. There lies your home, your story, and all of us, still shining.